Hello, in this lecture I will try to answer the question, is the universe infinite? The universe is all space and time and their contents, including planets, stars, galaxies, and all other forms of matter and energy. The Big Bang theory is the prevailing cosmological description of the development of the universe. The Big Bang event is a physical theory that describes how the universe expanded from an initial state of high density and temperature. According to this theory, space and time emerged together 13.8 billion years ago, and the universe has been expanding ever since the Big Bang. While the spatial size of the entire universe is unknown, it is possible to measure the size of the observable universe, which is approximately 19.3 billion light years in diameter at the present day. It is impossible to know for sure if the universe is truly infinite. The observable universe is definitely finite. It is that part of the universe which is within 13.8 billion light years of us. The number 13.8 is because it has been 13.8 billion years since the Big Bang. So any part of the universe that is more than 13.8 billion light years away from us will not be visible or observable, since the light from those areas cannot have reached us by now. Cosmologists assume that there is a significant part of the universe that is outside of our observable portion of the universe, but it is impossible to say for sure that it is infinite. The standard cosmological assumption is that the universe is homogeneous and isotropic. That is to say, it has no privilege or unique point. These assumptions seem to be correct and is confirmed in our observable universe. The universe looks the same in all directions, and on a large enough scale, the universe seems to be homogeneous. If the portion of the universe that is not observable is also isotropic and homogeneous, then it could be that the universe is truly infinite. One piece of information that is needed to determine if the universe is infinite or not is to know the curvature of the universe. There are three different regimes of curvature. It could have a positive curvature. It could have a positive curvature, which is like the two-dimensional curvature of the surface of a sphere. Yes? That is to say, the universe closes inward and it is finite, like the sphere. The other possibility is zero curvature, which is like a flat plane, with zero curvature. Then the universe is not closed but infinite, as the flat plane that is also not closed. The universe also is not closed and it is infinite. Or negative curvature, which is like the surface of a saddle. Yes, if the universe is with a negative curvature, then the universe is like a saddle, and the universe in that case is infinite. Then the universe is not closed at all, and it is infinite. If the universe is isotropic and homogeneous, and the curvature of the universe has constant positive value, like this, then the universe will be finite, just as the surface of a sphere is finite. On the other hand, if the curvature of the universe is a constant of 0, then it is like a flat plane and it is not at all curvature. With 0 curvature, then it is like a flat plane. And the other possibility is that the universe has a constant negative curvature, like a saddle. That is to say, the universe opens outwards like the saddle and never closes. The universe would be truly infinite. Do we have any measurement of the amount of curvature that the universe has? Yes, there is. The standard model of cosmology, which successfully fits all well-measured cosmological information, has a parameter of total omega, which is related to the curvature. If total omega is greater than 1, yes, then the universe is positively curved, like and the universe is like a sphere. If total omega is exactly 1, then the universe is a flat plane. And if the value of total omega is less than 1, the universe is negatively curved, like the shape of the universe is like a saddle. The best measured value is total omega is that the total omega is equals to 1 plus minus 0.12. Okay, and if total omega equals to 1 plus 0.12, that is 1.12, then it is greater than 1, total omega is greater than 1, then the curvature of the universe is positive, and the universe is in the shape of a sphere. Okay, so if total omega is greater than 1, and then the universe is like a sphere. that is closed. The universe is closed, and if total omega equals to 1 minus 0.12, that is equals to 0.88, that is less than 1, then the curvature of the universe is negative. Yes, omega is less than 1, then the curvature is negative. The curvature is negative. Then the universe is in a shape of a saddle. Okay, the universe is in the shape of saddle, and the universe is infinite, which obviously could there are the three possibilities exist. So it could be the total omega equals to a value that greater than 1, or total omega could be less than 1, or it also could be maybe 1. So obviously it encompasses everything from positive to 0 to negative curvature. Okay? Because as I already said, total omega could be greater than 1, or equals to 1, or less than 1. So the universe could be closed, or and finite, or it could be open and infinite. So there is no definitive answer to this point, at this point, but the universe is consistent with having 0 curvature, because total omega is close to 1. It is 1 plus minus 0.12. It is very close to 1. So we really don't know if the universe is infinite at this point, but since the value is close to flat, because it's close to 1, even if the universe is positively curved and finite, it would definitely be much, much bigger than the observable universe. So we can summarize that the size of the universe beyond the observable universe is unknown, since it cannot be observed. At the moment, we don't even know if it is finite or infinite. But there are speculative estimates by theoretical physicists who say that the size of the universe beyond the observable universe should be at least 250 times larger than the observable universe. Other estimates speak of a universe whose size is even inconceivably larger, even if still finite. Okay, thank you very much.